this question. Using the principles of physics, it can be shown that the height h reached by an object thrown up vertically with speed u meter per second from the surface of planet Solaris in time t is given by this expression. So the height when an object is thrown vertically upwards with an initial speed or with a speed of u meter per second, right, from a surface of a planet called Solaris, then the height with which the height to which this ball or this object would reach is given by the expression h is equal to ut minus half g into t square. So the height reached by the object which is thrown vertically upward from the surface of this planet is given by this expression, where g is given that g is the uniform reduction in the vertical speed of object due to gravitational pull of the planet, right? What is happening? For example, if we throw an object vertically upward, so due to the gravitational pull of our planet Earth, the velocity or the speed of this object slowly decreases, right? It would rise up to a point, I'm calling it a maximum height, and it will come down, right? So that height is given by this expression, and g is the uniform reduction in its vertical speed. Now it is given that object was thrown up vertically with an initial speed of 100 meter per second. So an object was thrown up vertically with an initial speed of 100 meter per second, right? It was observed that the speed of object was 75 meter per second at the end of 5 seconds. So after 5 seconds, its speed has reduced to 75 meter per second. So after 5 seconds, it is given its speed becomes 75 meter per second. So we can say 25 meter per second of speed has reduced in 5 seconds of time. So from here I can find the value of this constant g as, because g is the uniform reduction in vertical speed, and how much is the uniform reduction? I know 25 meter per second has reduced in 5 seconds, so we can say 5 meter per second square is the uniform reduction, or we can say speed is reducing by 5 units or 5 meter per seconds in 1 second, right? So from this information we find the value of this constant. Now what is the maximum height in meters that the object will attain from the surface of the planet? We have to find the maximum height that this object can achieve, right? We have initial speed as u, right? I am assuming that for some time t, that for time t, this object will attain the maximum height, right? I am assuming that for some time t, this object will attain the maximum height. So that maximum height would be how much? ut minus half gt square, right? And u is 100 in this case, and g I know, we have found g as 5, so it would be the maximum height, or let's just simplify it further, so it becomes 2.5 t square. So this expression, or we can say this quadratic expression, would be the maximum height. So precisely we have to find the value of maximum of this quadratic function. We have to find the maximum value of this quadratic function. Right? We know the maximum value of quadratic function is if the function is ax square plus bx plus c, the maximum of this quadratic will lie at x equal to minus b upon 2a, right? And that maximum would be minus discriminant upon 4 times of the coefficient of x square, right? So we have to find the maximum of this quadratic expression, and it would lie at x equal to minus b by 2a. So the maximum of this quadratic will lie at t is equal to minus b. B is the coefficient of x, or the coefficient of this variable. So minus b means minus 100 divided by 2a. 2a means 2 into minus 2.5, right? Cancel these terms, it becomes 5. So at t is equal to 20 seconds, this object will attain the maximum height, and that maximum height would be 100 into t. So 100 into 20 minus 2.5 into t square. T square would be 400, right? So it would be 2000 minus 1000. So the maximum height attained by this object would be 1000 meters, or whatever the unit is. So in meters. So correct answer to this question would be option D, right? Nothing. Only the length of this question is very larger, right? This question is there are 4, 5, 6 lines. Okay, next.